Welcome everybody and thanks for joining our introduction to Xamarin.Forms. Rob talked about how we can use Xamarin to build native applications by using C# and reuse most of our code across all platforms. The example that we will use is a small trivia or quiz application that will run on iOS, Android, and of course on the Windows platform. Over the next 2 hours, I'd like to show you how you can use Xamarin.Forms to build this application. My name is René and I'm an instructor at Xamarin University. Xamarin University is the place to go to if you want to become an expert in mobile development with Xamarin. You will have access to live instructor-driven classes, which cover everything from introductions to up to the advanced features. You will also get access as a subscriber to 8 office hour sessions, where you can talk to an instructor one-on-one and maybe have your code reviewed, or get input on a specific problem. You will also be introduced to a fairly large community. This includes a private forum where you can chat with us instructors and also talk to other university students. If you take all the required classes, you might choose to become a Xamarin certified mobile developer. This is an optional step, although we highly recommend it, because it tells everybody that Xamarin endorsed you as an expert in mobile development. Now let's see how we can build our Xamarin.Forms app. Xamarin.Forms is a cross-platform UI framework. We work with abstractions of the UI. We have a lot of standard controls, like entry fields, we have static text labels, we have buttons, but also more complex controls, like list views. And all of this runs across various platforms. So here on the left-hand side, you see we support Android, iOS, and of course Windows. We manage our controls using a very flexible layout engine. Xamarin.Forms is available as a NuGet package, and there are other add-ons available, like you can have mapping support. We also abstract navigation for you. If you're not happy with the controls that are in there, well, you can create your own, or you can extend the ones that already exist. The most powerful feature of Xamarin.Forms is probably that you can create your pages, your content, by using XAML. We have a live previewer built into Visual Studio, which doesn't require you to rebuild your app. You will see what your app is going to look like as you type. I said that we work with an abstraction of the UI. We work with models of the UI. So here you see an example. We are creating a Xamarin.Forms.button. It has got properties, and at runtime, if we deploy that and run it on an Android platform, this will turn into an Android.widget.button. And if we run it on iOS, this will become a UI button. And if we run it on the Windows platform, well, then it's going to be a system.windows.button. So Xamarin.Forms applications really are native applications. If we want to create a Xamarin.Forms app, we're going to use one of the templates which are available in Visual Studio. You find them in the template section, Visual C# cross-platform node. Here you see highlighted the blank app template, which creates a Xamarin.Forms project based on a portable class library. Xamarin.Forms projects can be created using either a PCL or using a shared project. Shared projects were introduced with Visual Studio 2013, update 2 I think it was, and they allow you to share at the source code level. Then we have the portable class libraries where we share binary content. Let's have a look at shared projects. The idea of a shared project is that we share at source code level. That's important because it's different from how a PCL works. We're going to see that in a bit. We add a new project to our solution, which contains all of the source files that we want to be available for all the other projects that we reference the shared project from. It's not limited to source files, by the way. You can include different types of assets, so also images, videos, whatever you need in the projects. If you then compile the Android, the iOS, or the Windows app, all the files from the shared project behave like they would be copied into the currently built project. The nice thing is that all the normal refactoring tools still work. All the IDE support works. And shared projects allow you to use the platform-specific features. So because the file feels like it is being copied into the project, it is perfectly valid to use Android-specific APIs or iOS-specific APIs, and of course also Windows-specific APIs. You just have to make sure that it's only called on that specific platform, maybe by using conditional compilation. Let's compare this to portable class libraries. So as we just heard, one of the great advantages of shared projects is that we can use all available API. Now that's a bit different with PCLs. If you create a PCL in Visual Studio, it's going to prompt you for the initial supported platform list. And at the end of this selection, you have decided on a profile. The profiles are defined by Microsoft, they ship with Visual Studio, and this profile will decide which APIs you can use. So you can imagine, the more platforms you pick, the less API you have available. So what's the advantage then of a PCL? Well, a PCL really generates some output. You're going to end up with a DLL, and you can share this DLL with others. So maybe you don't want or you just cannot give away your source code. So here you have a chance to share at a binary level. If we cannot access all the platform features from within a portable class library, well, what are we going to do if we need to use something that is platform specific? Like, let's say we want to dial a phone number. That's absolutely platform specific, and it's completely different API depending on the platform that we're running on. Now, in a shared project, this would be easy. We could just use the platform specific APIs. In a PCL, we often introduce platform abstractions. This means we would create an interface, some sort of contract that gives our shared code, our PCL, access to a method that allows us to make a call. And then we implement this interface platform specifically. So one time for iOS, once for Android, and once for Windows. And to put everything together, we're going to use a technique, maybe like dependency injection, where we pass the concrete implementation to our PCL. So here you see three options: constructor injection, we pass it to one method, or we use property injection. So the question is now, which project would you or should you use? Shared projects, portable class libraries? And there is no clear answer. It depends a lot on personal preference, on your team preferences. Maybe it even depends on the project that you're working on. So for smaller apps with smaller dev teams, where you have all the projects loaded into a single solution, and maybe you intend to update them all simultaneously, then I'd say a shared project makes a lot of sense. They are simple, they're easy to manage, they support extensibility in ways that a PCL never can. However, we must have access to the source code to use them. There's no distribution model beyond that. So when to use PCLs? Well, maybe if your team is larger and you don't want to include all the projects, or you have a true reusable component, then it makes a lot more sense to turn to PCLs. However, they force you to put some more architectural thought into your design. Because, as we just saw, we cannot simply use platform-specific APIs. And maybe the best approach is to just mix and match them in the development. So maybe you have some things built in a PCL that you intend to use across multiple applications. And then you have some shared local logic that is specific to your project, and you put that into a shared project. I think it's always good to see something in action to get a better understanding of it. So I prepared a little demo to compare a shared project versus a PCL. Here in Visual Studio, what we see here is a solution. It's a Xamarin.Forms solution, and you don't have to understand all the details of how this solution is created because we're going to cover that later. But the interesting bit is that we have platform-specific projects in a Xamarin.Forms solution. Here we have an Android project and we have an iOS project. And then we have all of our forms code either in a PCL or, like in this case, in a shared project. Currently, this shared project, it only has one file. That's the application class of Xamarin.Forms. So this is all the platform agnostic code, platform agnostic UI. I want to have a look at the iOS and Android project. In the iOS project, we find an app delegate, just like with any iOS project. And in here, we see I added some logging. In order to log something on iOS, you typically use console.writeLine. The native API really is NSLog, but that's not directly exposed in Xamarin iOS, so we use console writeline. Now, what do we use on Android? Well, we can have a look at this too. Here on Android, in the main activity, we typically use android.util.log.writeline. You can specify a priority here. You can have your own tag. This allows you to filter the output, and then you log the actual message. And whatever we log here will be shown in the Android device monitor in logcat. So I can switch there. So here we have the device monitor. I see all the connected emulators and devices, and I can filter by a specific tag. So that's the tag here. And if I run my Android application now, I'm gonna set this here as the startup project. I can deploy that. And we will be able to see this output in logcat. And that's no big surprise. This is native Android code. Of course, this builds and deploys and works just fine. Wait for it to complete. Still waiting for a label to appear here. There, it's been initialized. Let's switch over here to the device monitor. And we see if I filter by my log tag, I see this output here logging on Android. And similarly, I can run the iOS version, and we will see the console writeline output in the output pane down here. So now this is a Xamarin.Forms app that we have here. What if I want to create some log statements from within my shared code? So in here, in my app, maybe I want to log that my app successfully started. I'm going to create myself a little helper method. I'm going to call it logit, and I want it to accept a string. I could say logging from forms project. And my logit method is just going to be a public static void method here, which takes some message. And since I'm using a shared project, I can use platform-specific APIs. So we just saw the Android project. This means I'm going to copy this line here from the Android project, paste it over here, replace that with my actual message, and there we go. And again, I can build and run this, and we should now see both in the output, logging from Forms project and logging from Android project. I see compiler accepts this. The reason is our shared code, everything that is in that shared project, behaves as if it was copied over to the Android project and is built together with it. That's why we can access everything that is Android specific or iOS specific or whatever platform we're building. So if I switch here to the device monitor, you see logging from Forms project and logging on Android. What happens now if we try to build the iOS version? So if I make this one here the startup project, I'm going to build for iPhone simulator, shared demo iOS. I try to build this. Now we will get an error. Here it says something failed. And if we look at the error message, no big surprise, it tells us the namespace Android does not exist in this context. So you cannot use android.util.log.writeline from within iOS project. Now our app.cs file, it behaves as if it was part of the iOS project. And that does not exist on iOS. The IDE supports us here. If I hover over that here, look at the tooltip that we see here. We get information about the method here. It says there's one more overload. But to the very right, there's this little triangle, the yellow one. And below we see shareddemo.droid. Here it says available, and for shareddemo.ios it says not available. So the IDE is aware that we are using that shared project both from iOS and from Android, and tells us, look, this API that you're using here, it is available on Android only. You can use it, but I just wanted to let you know if you try to build the iOS project, that's not going to work. So to fix this, we want to use console writeline on iOS. So let's just do this. We add this here. I'm going to put our message in here. And Now we just have to tell the compiler which line to execute on a specific platform. Now, since all of the code is really built together with the currently selected project, we could just use conditional compilation. So we could do something like this in here. I could say if we are on iOS, that's a constant that's always defined. We use this, otherwise we use that. And if, I'm going to move this one here into the else branch, down here. Now if I try to build the iOS version, I can put a breakpoint in here, run that, and we will see that it's going to hit this breakpoint. Here's the emulator, the simulator, and there we go. Console write line is hit, and it will not execute this one here. So that's working as expected. And of course, if I now build the Android version again, it's going to execute this one. So this is something that we can do exclusively with shared projects because we share at the source code level. Of course, remember that slide from before when we talked about this can lead to spaghetti code. That's exactly the cause here. If you have a lot of this if-else conditional compilation tags in here, it can be a bit hard to maintain your code. So there's cleaner ways of doing this, like you could use something like class mirroring or use partial classes, partial methods. That helps you to keep it all nice and tidy. But now let's have a look at the other option. What does the same version look like when we use a PCL? I have another project here. I want to switch to that here, PCL demo. That's it. So similar setup. Again, we have a Forms project. It has got an Android version here. It's got an iOS solution. And just like before, I removed the other platforms to keep it simple, just demoing two platforms here. But now our shared code is a PCL. Notice the different icon. I can build this separately from the other projects. It's going to generate its own output. We're going to end up with a DLL. So let's see. If I start here again with my Android project, I go into the main activity. I can, of course, again, do the same as before. So I see if I remember the namespace. It was android.util.log.writeline. Then we had a log priority. We had info. It was my log tag. And it was logging Android here. And of course, we can use console write line over on iOS. And again, same challenge. What if we want to log now from within our Forms code? We again have an app.cs file. It looks just the same, but this time that's a portable class library, which means we no longer share at the source code level, but at a binary level. Oh, let's just add our method here again. Public static void logit string message, like that. And we call it here logit logging from forms. Let me scroll this a bit up here. And now if I just copy this line of code here, the android.util.log, I paste it in here. Immediately I get an error saying the name Android does not exist. It proposes here to fix that. I can hit Control dot, but it won't be able to resolve that. There is no Android namespace in a portable class library, simply because the library has to run on various platforms. We don't know who's referencing this library. So we have no access to platform-specific APIs. Bummer, huh? So let's get rid of that and try something else. We could say, yeah, then let's just use console write line, right? So use console write line. We know that is available on Android and on iOS. And again, error, I can't use that. So the thing is, parts of system I/O are available in a PCL, but not console. And remember, there's this workaround, so we could use debug write line. that resolves. We could resolve using system diagnostics and have debug write line. Debug write line is gonna write to the output pane in here. So that kind of works, would be a workaround. But what if we don't want that workaround? What if we really want our output to again appear in logcat on Android? Well, then we gotta think about abstractions here. Now there are different ways of abstracting that, and I'm just gonna show you one that is relatively simple. We can use a delegate to solve that. So in here, I'm going to create a public static action that takes a string as a parameter, and I'm going to call this native log. Let's make that a property, getter and a setter here. And then our login method, it can just call that. I can say native log, use the invoke method here, invoke that, and pass along the message. And now our platforms, that is the iOS platform, the Android platform, they have to provide the implementation for this, because only the concrete platform has access to the APIs that we're looking for. So this means for our Android version, we go back into our main activity, and here we are creating our forms. We're calling forms init. That's already where we want to have our native logger. So here we just use our app. We find the native log, and we set this to a delegate. I can use a lambda here. And I'm going to copy this here like that. And we want to output our message. So this means the message that we have becomes Android util log write line. So now our shared code is able to call into the native code. And of course we wouldn't need something similar over here on iOS. Let's use this here. app.nativelog. We're gonna have our message. And we say here we really want to use console write line. I can go back here into my app. Let's put a breakpoint in there. And I want to run the Android version, see if that works. And it hits the breakpoint, and we can have a look at what native log is. To show it, system action string, multicast delegate. Let's see where it's taking us. I can step into it. And we really end up in our main activity executing platform-specific logic. Just wait for this to disappear. And if I switch over here to the device monitor, where is it? There. It of course appears in here too. So that's not different from before. I could now run the iOS version with similar results, but it's just going to use console write line. So the moment we use a portable class library, we have a clear separation between our shared code and the platform-specific code. We need to think about abstractions. And what I used here is, well, a real simple version using this property. This is a good solution if you only have one sort of dependency. If you have multiple dependencies, it can be a bit tedious for somebody who's using a library to wire up all of these properties. So there's other solutions. Typically you would create an interface, a contract, and then have the platform implement that. If you're interested in more details, how to solve that, how to create code that really runs cross-platform and is reusable, I invite you to join our classes at Xamarin University. We cover this in 2 classes, an introduction and a more advanced one. And there you can learn everything about service locators, factory methods, dependency injection, inversion of control in general. Now let's go back here to our slide, and we want to move on. And now it's time to really have a closer look at Xamarin.Forms, at the project structure. You just saw me using 2 Xamarin.Forms projects without really talking about the details. no matter if we create a project based on a shared project or on a PCL, this is what the structure will look like. We have one project in the solution that contains all of our business logic, and it also contains the abstraction of the UI. That is the Xamarin.Forms project. That's either a portable class library or a shared project. And then we have platform-specific projects. They act as a host, so they reference our Xamarin.Forms project. For simple applications, there's typically no need to do any work in these platform-specific projects. However, you can do this, of course. So it's always possible to reach down to the platforms and add platform-specific features in there. As we just saw, we might have to use abstraction for certain things. But always remember, you are building native apps with Xamarin.Forms. If we look into the Forms project, here it's, like I said, the portable class library version. Initially, there's one file in there. That's what the template generates by us. And that's either named app.cs or it has the name of the solution. So it could also be phonework.cs depending on the template that you're using. This is the entry point to our Forms application. Oh, we're going to explore that a bit later. Here's a graphical representation of what the dependencies in our Forms project look like. All of our host projects, those are the native ones, they depend on the shared code. That means on our PCL or the shared project, but not the other way around. And I'd say, let's just have a look at it. As always, I quickly got a switch here. So here in Visual Studio, I'm going to start a new project. We find the Xamarin.Forms PCL version under cross-platform, blank app, Xamarin.Forms portable. That's what we want. I'm going to enter the name here, call it exam, and confirm by pressing OK. And it will now create all of the projects. Visual Studio is going to add a project for iOS, one for Android, one for Windows Store, a Windows Phone version, and a UWP version. It's going to take a while. It's now doing the Android version. And you can see here at the bottom left how it's adding the NuGet packages. So here it's Xamarin.Forms 2.2.0. The current release, I think, is 2.3 something, which means we will have to update them once the project has been created. So let's just wait for this to complete. It's adding iOS now. Here's Windows Phone. Now we have to pick which version we want to use for the Windows 10 UWP project. So I'm just going to confirm. Keep the default value. And it will also create that project now. Here we have the Windows project. By the way, here at the bottom left, you just saw how Visual Studio told me that it is successfully connected to my Mac build host for the iOS version. We need a Mac in order to build that. And yeah, looks like it is done. You can see the project structure here. I'm going to collapse all of those. And we will have a look at those references. Remember this slide? We have references from the host projects to our portable class library in this case. So let's see what's in there. If I start with the PCL and look at the references, we see there's Xamarin.Forms Core, Xamarin.Forms Platform, and XAML. Then we can have a look at, well, let's just pick two platforms here. I'm going to pick iOS. In the references of iOS, I find one that points to the PCL, which contains our Forms code and also our business logic. That's the exam library. And then we also have Xamarin.Forms references, and one is particularly interesting. Here's one that says Xamarin.Forms.platform.ios. And we have one on Android that says Xamarin.Forms.platform.android. This contains everything that is specific to the iOS or the Android platform. This turns our UI models, our forms views into something that is UIKit, iOS specific. I can pick another one. Let's just pick, I don't know, Windows Phone here. Look at the references. And you see, once again, we have Xamarin.Forms.platform.WinRT and WinRT.phone in here. Again, something that is platform specific. The other thing that we find in all of our host projects are ways to kick off the Xamarin.Forms application. So let's again take iOS here as an example. If I look at the app delegate, you will find that our app delegate, it derives from the Xamarin.Forms platform.ios.forms application delegate. If you have worked with iOS before, that typically app delegate derives from UI application delegate. And this is implemented by Forms app delegate, but it adds additional features. So that's required by Xamarin.Forms here, that we derive from this particular class. You don't have to do this manually. The templates are creating that for us. And then we have two more interesting things down here. Every platform has got this call here to Xamarin.Forms.init. And afterwards, we find a call to load application, and we pass in an instance of the Forms application. This is now code that we write. The new app that we have in here, that's the app file that we find up here in our exam portable class library. So this really moves execution over to Xamarin.Forms. And we also find that on other platforms. Let's just pick Android here as another example. In the main activity, you see our main activity, it derives from a special activity, from a Forms app compat activity here. We can even make use of material design in here. So that works also with Xamarin.Forms. And we have a call to the base on create, just like any other Android app. And again, a call to forms.init. Here on Android, it needs two additional parameters. The current activity and the bundle has to be passed in. And once again, we find this call to load application to kick off the actual Xamarin.Forms application. And this is true for all platforms. So I can also look at UWP and the other Windows platforms in here. We will always find this init call and the call to load application. Now, before we move on and run this app, let's make sure we're using the latest version of Xamarin.Forms. So this means we're going to update everything. Let me clean up a bit here. We don't need this one. We don't need that one. And instead, we will need our app. And no, we don't need the app. So what we really need is the package manager. I'm opening the NuGet package manager for the entire solution here. That's a real nice feature of Visual Studio. I'm going to go here. Manage NuGet packages for solution is what we want to pick. Let's see what it has for us. Here we see all the currently installed packages. Down here we see Xamarin.Forms. And the packages that you see here, those are dependencies that Xamarin.Forms requires for Android. So we have the Android support v7 media router, package card view, app compat, support v4, support design. All of these are required by Xamarin.Forms. Now let's check the updates tab here. And I recommend that you update Xamarin.Forms first and then maybe the others. So don't just go ahead and select all packages, because there's a chance that it's going to update the Android support packages first and later the Xamarin.Forms package, and that can lead to an inconsistency because the dependencies no longer match. So I typically start here and let Xamarin.Forms decide which of the support packages or which specific versions it would like to pull in. So let's select that one and click update. Here on the right hand side we see the versions that are installed. It's version 2.2 of Xamarin.Forms, and interestingly it's 2.0 for UWP. So let's see if it's going to pull all of these to the same version, which should be the latest stable 2.3.2. I'm going to wait a bit for the package manager to complete. Here we see on the left hand side how it's updating the Android support packages. You see it's adding a lot of them. There's other dependencies these days. Here we have Recycler View as a dependency. Now it's adding Xamarin.Forms Core. And now also that was iOS. That's adding Windows Phone. We can see this down here. That should be done any second. I think that's it. Let's see. Some package failed to uninstall, restart Visual Studio. Yeah, let's do that. We want to restart Visual Studio, and then we should have the latest version installed. It's reopening our solution. And when it's done, Let me go back to the NuGet package manager. Just want to double check everything is now using the correct version. You see here we still have 9 pending updates, and those are all for these Xamarin Android support libraries. You should not update them. Like I said, this can lead to inconsistencies with Xamarin Forms. Now if we check our Forms package, no update available, and really all of our projects are now using the correct version. That's great, and I'd say let's go ahead, close this, and of course we want to run this app that was generated here from the template. We want to run this on various platforms. So I'm going to start with the Android one, which means I'm going to right-click Android here, set that as a startup project. You can see the configuration up here. We built the Android project, and we're going to deploy it to Visual Studio Android emulator. It's building. We should see the emulator popping up. Here it is. It's deploying the app to the emulator now. And we're running our very first Xamarin.Forms Android app. It's still going to take a while to load all the assemblies, and here it is. Welcome to Xamarin.Forms. That's what we get when we run the app as generated by the template. Now let's try this on iOS. I'm going to stop debugging. I'm going to make the iOS project the startup one. And we want to build this for the simulator. We could also build for a physical device that is connected to your machine, so that also works. But here I want to show you that in the simulator. Build the iOS version. I can select the simulator that I want to use here. So let's just use the iPhone 5S. And I'm going to build and deploy it. And we're going to see the iOS simulator popping up here in Visual Studio, which is another great feature. So you can mirror the iOS simulator to your Windows machine. You don't need physical access to your Mac build host. It's gonna pick it up there, and you see it here on the Windows machine. Simulator is now loading. It's deploying our app. And here we have the iOS version. Welcome to Xamarin.Forms on iOS. Even though you probably can't tell, this really is a native iOS UI. This is a native UI label here that we see here. Here at the top, we have a real navigation bar. And so we saw Android and iOS. I want to pick a third platform. Let's just use UWP here. And you know by now how this works. I'm going to set this as the startup project. Make sure that I pick the correct configuration here. So for me, that's x64. And I'm going to deploy it to the local machine. Run it. It's building, and we will see a UWP app. We see now it created everything. It deploys the UWP application, and here it is. Still initializing. It's loading some symbols. Now Visual Studio has started the debugger. And here we have our UWP app. Welcome to Xamarin.Forms on UWP. And I've of course now run the Windows Phone app too, but we saw 3 platforms already. We covered all the popular ones. It's Android, iOS, and UWP. You see, it's really easy to create a cross-platform app, even though this one is not having a lot of interactivity yet, but we're gonna add that later. Before we switch back to the slides, let's have a real quick look at the structure here. So here you see the projects, and up here, that's the Xamarin.Forms project. And in there, we find the one and only application file. Here it is, app.cs. Our app derives from Xamarin.Forms.application. And we want to have a closer look at that. We already saw this app.cs file. I said that's the entry point to our Forms application. There are really 2 types that you will work with the cross-platform code most of the time. It's the application class and its subclasses of a page. The app class, this is where your application starts. It's located and used by the platform-specific code. It's also, well, where you have a chance to react to the application lifecycle. I'm going to show you that next. So you want to be informed if your app is going to go into the background, if it's resumed from background. The page is used to display a single screen to the user. You can compare that to a view controller on iOS or an activity on Android. A page defines the UI. It does that either in code or it uses a markup. XAML is supported here. And it also provides the behavior for the screen. So you would have your event handlers in there, for example. And the application class will always identify the starting page. It's got a property that allows it to do that. So let's have a look at the application class. This is where everything starts. There is only ever one application. And if we look at what's available in this application, we'll see that first there is a current property. That's a singleton that allows us to always get to the application. So from whatever page we're currently on, we can access our app. And our app is also capable of keeping track of what's going on with itself. So we often want to know in mobile applications, are we leaving the app, are we returning to the app? Just think about an application where you maybe have some news feed or something and you want to update as soon as the user returns to the app. So you want to add some code to the onResume method here, for example. We have events in here that will fire if a page is presented. For instance, after a login process, you want to update the current content. And finally, probably the most important property in there, that's the main page. The main page property is used to identify the very first page that our app is going to display. Here's another nice feature of Xamarin.Forms. It has a built-in way of saving user properties. So that's a typical task in a mobile app. You maybe want your users to, or allow them to save their login username. Where do you store them? Well, storing things is a platform-specific operation. You could maybe have a SQLite database, but if that's too much for your app, well, then just use Xamarin.Forms properties. This is a key value bag that you have here. It supports single types like strings, integers, and the properties bag is saved automatically if your app is pushed into the background. If you want to save them explicitly, you also find a save properties async method in the app. Be careful with the application class, by the way. On Windows, there's also an application class, so don't confuse them. There's also one on Android. If we talk about the application class today, we always mean the Xamarin.Forms one. And this brings us to the creation of pages. Pages represent the content of our application. The app identifies the first page, and then onto that page, we put our UI controls. In Xamarin.Forms, those controls are referred to as views. So let's see what types of pages we have there. Page itself is an abstract base class, and we typically work with one of the derived classes. The one that you will use most of the time, I presume, is going to be the content page. It has got a content property, and we can assign one single visual element to that. So here on the content page, you can place one button or one label or one entry, whatever. If you wonder now, how is that useful if I have a page that only displays one button? Well, the magic here is that we're going to talk about layouts later, and a layout is also a visual thing, and into that layout we can then add multiple child elements, of course. Another page that you will use often, I guess, is master detail page. Master detail page has got two properties, which are surprisingly called master and detail. They both accept a type of page, so it manages two pages, which are probably again content pages. And the nice thing about master detail page is its adaptive behavior. If you use a master detail page and you run your app on a tablet, it's going to render side by side, kind of like UI split view controller on iOS. Now, if you run the same app on a phone, it has got its own implementation of an overlay layout. So like draw layout on Android with the hamburger button. So this is really nice implementation. Oh, and let's see what's next. We have the navigation page. This is a bit special. Navigation page is typically wrapped around existing pages. And it then enables you to have a navigation stack. So you can push pages onto that stack. You can drill down a hierarchy and you can navigate back to the previous page. If you have ever used an iPhone, then you probably use UI navigation controller with the back button at the top left. And on Android, if you navigate to a new page, you can use the soft key to navigate back. And that's what the navigation page enables us to do here. Now the last one I want to bring up is the tabbed page. It also has a collection of children, which are again pages, and it manages them in a tab interface. So on iOS, we're going to see the icons with the descriptions at the bottom of the screen. On Android, they will show up at the top. We can swipe between pages. And again, this just works. You only create the pages, you assign them to the children collection, and you're set. Now that we know how the pages work, let's apply that knowledge. I'm going to switch over to Visual Studio. That's where we left. We inspected our application subclass. And here you see, if you look at the constructor, how it is creating an instance of a new content page, and it's doing this in line. Now you can do this. However, often it is better to structure your app a bit. So you will have one page per screen of your app. So you have different operations that are possible in the application. You want a subclass content page and add it. And we want to do exactly that. I'm going to take this piece of code here and move it into a separate file. So we do this in here. We operate only in our portable class library. There's no need to touch the platform-specific projects. We're going to add a new item in there. And we'll see that there are templates for pages. Here we see there's one for the Xamarin.Forms page. That's what we're going to use. You will also find a Forms view. That is a bit like a user control. This is a combination of UI and behavior that you can reuse in multiple pages. And then we have a Forms page that is backed by XAML. We're not going to talk about XAML now. Jesse is going to introduce you to XAML pages later. So for now, let's stick with the Forms page. And we want to call that here our main page maybe. Let's add that here. It's been created. You see main page derives from content page, and it already has some content built in. Here we have this content property. Remember, a content page can host one visual element. Here that visual element is a stack layout, which we're going to discuss in a bit. But I want to remove all of this here now. We create our UI in the constructor, and I'm going to copy over what we have in our app. I'm going to switch back here. You see that's what we had in there. Well, let's remove that. I'm going to cut all of this and switch back to our main page. Paste it in here. Well, we have to change this a bit. We no longer have to create an instance of a content page, but instead we just want to set this page's title here. There it is. And we want to set its content. I'm going to format that a bit here. Like that. Here we go. Add the semicolons. So title and content, these are properties of the content page of the base class. And now we want to use our main page. I'm going to go back into my app file. Here we set the main page. You see this no longer works here. And we wrap our main page into a navigation page. The navigation page, it adds the bar at the top, and it enables us also to push other pages onto the stack. Let's just use a new main page here. And using this technique, you can really organize your app. And I'm going to deploy that. Well, let's just run this here on UWP because it's the one that is already selected. And we will get exactly the same result, but now we structured our app a bit better. I see it's loading. And here we go. Still saying welcome to Xamarin.Forms, still the same content. With that, let's go back to our slides here. Let's see what kind of views we have, what controls are available. Well, the short answer is pretty much everything you would expect. So here you have an overview, it's not complete. You also see how the views will be rendered on iOS, and you can clearly see that these are real native representations. it's not that if we look at the entry, for instance here, which is an edit field, it's not that it just looks like a native iOS control. No, it is one. It really is a UI text field, just like the button is a UI button that you see here. So here we have simple controls like labels, images, entries, buttons, but also more complex ones like list views, which is not shown here. Let's have a look at some of those, particularly those that we will use in our application that we want to build today. Here's the button, the Xamarin.Forms button. We just create an instance and it has got a property. In this case, it's text, where we can assign the text that's going to display. And in order to react to a click, to a tap on that button, we use the clicked event. It's using the normal event handler signature. So we get the sender, we get event arguments. And please note how this is, well, unified across all platforms. Let's just think about iOS for a second. If you're new to iOS and you come from any other UI framework and you create a UI button, you will start looking for some sort of click or tap event and you won't find it. Because Apple uses touch up inside to react to a click. Now you don't have to worry about these kind of things here. It's just clicked across all platforms. Another example, here we have the label. Again, the label has got various properties. Here we can set the text, we can set the color, we can set the font, and it will render as a native label. Last one, entry, which allows our users to enter something. If you tap in there, it's going to bring up the virtual keyboard. It supports a hint for the keyboard to use. So if you know that you would like your users to enter an email address here, you could set that keyboard hint to email. It's going to show the appropriate keyboard then. You can also provide a placeholder text to give hints. So long story short, it's exactly what you would expect from a powerful UI framework. So as you have probably noticed, our view classes, they have a lot of properties that we can use. These properties let you adjust the visualization. It will influence how a control will be rendered on a platform. And most of these properties, they will do exactly what you expect. But you got to be aware that they can be interpreted differently on each platform. So there are cases where a property might even be ignored. And that's the case if the platform simply doesn't support that particular feature. So to give you an example, Windows Phone tends to dictate a bit more how controls are spaced out, also how thick borders are. So it can happen that if you set properties which are related to border thickness, that they do not actually affect the visualization. What does this tell us? Even though we use one framework to target multiple platforms, it's always very important to test on all of the platforms. We can't just safely assume that if it builds and runs on iOS, that it's going to look great on Windows Phone or on Android or UWP. You really must test the app on all of these platforms. And this brings us back into Visual Studio, where we want to try out and use one of those controls, actually two. So let me switch over here again. We want to edit our main page. Maybe I should rename that to something else because it's a bit confusing here, saying main page equals new main page. Let's just change this here. We want to make this one here maybe a home page. And I also want to change the file name here. Like that. Now that's a bit clearer, I think. And we're already in the correct file. So let's change this. Currently we have what do we have? We have a stack layout. Our stack layout has got a label in there, and I'm gonna remove this label for now, because what we're gonna do now is we wanna have a button in there instead. And as we click the button, we wanna change its text. So it's gonna show us the number of clicks. Well, let's think about that. What do we need? Well, first of all, we probably need some sort of counter. I'm gonna call that click count. Then we obviously, we need a button. So let's make our button in here. That's just gonna be a new button. Our button is gonna have a text. So let's set that. Well, we're gonna set the text to click me. Right. If we want, we could also play with the colors in here. So let's have a, I don't know, let's have a blue background color. You see that Xamarin.Forms is also abstracting colors for us. Here's a color enumeration built in that we can use, which will then of course also translate into something platform specific. I'll make, I don't know, white color. There we go. And where we had the label before, that's where we're going to add the button now. So here we go. I'm going to add the button here into the stack layout. The green line here reminds us that we are not using that variable yet. Yes, we are about to change that. Our button has got a clicked event. I'm just going to use that. Plus equals here. Now I can use an event handler method. I can use an anonymous delegate. I can use a lambda, whatever I prefer here. So let's just use a lambda. Now where the button is clicked, we're going to increase our click count. And we're going to update our button's text property. Button.text. I'm going to set that to clicked click count times. Now let's try this out. I'm going to run it again on various platforms. And yeah, let's start with UWP. And you see our button is a bit wide, but it is working. So clicked 4 times, working as expected. Let's try another platform. Let's maybe pick, maybe iOS, iPhone simulator here. And we want to build the iOS version, deploy it to our iPhone 5S simulator. Just to prove that we really know that clicked is going to translate into touch up inside. Here's the simulator. App is starting. And we have a beautiful blue button and it's working. And of course I can debug everything in here. So let me switch in here and I want to put a breakpoint in there into the event handler. There we go. Switch back to the simulator. Click it and you see this is hit as expected. And I can inspect the stack trace and can see where this is coming from. And we'll see that this is really triggered by native code. Let's use debug windows here. We want to see the stack trace. Here it is, called stack. Select that. You see down here, that's where we currently are in our homepage.cs. This is called by an iButton controller send clicked interface. And if we go a bit deeper, we notice here we are already on the iOS platform, an iOS button renderer, on button touch up inside. Here it is, really. So this is called from the native button, and I can continue here. And just like on UWP, it's also working here on iOS. And of course I could try that again now on other platforms, but the idea here is that we do not have to worry anymore about the platform differences. I always like to ask, if you were given the task to code this really simple app, a click counter, on 3 different platforms, or in our case we have even 5 in here, you'd be very busy. It's going to take you a long time to figure out what all the APIs are. And here with Forms, well, it's just, how long did it take us? 2 minutes? So you see, that's really nice. And with that, let's go back to the slides. We want to talk about organizing our page's content a bit more. The content page has got this content property. This means, as I mentioned before, we can only have one visual element on it. In the demo that we just went through, that visual element was set to a stack layout. And these layouts that we use here, they really allow us to organize content on a screen. They manage this content for us. So we never use pixel perfect layouts with Xamarin.Forms. We just tell it, well, here's some controls. I would like to have them aligned. I don't know, top to bottom, left to right, whatever. And it's going to handle us for us. And this sort of adaptive applications that we built here, they obviously run on various devices. They work on a phone, they work on tablets, they work on large screens. Let's have a closer look at these layout containers. There are several built-in layout containers, and of course, as always, you can create your own. But let's focus on the ones that are built in. We're going to start with stack layout. You already saw this in my last demo. We replaced the label with a button inside that stack layout. Stack layout is, I think, the most common one. You add some child elements into it and it's going to arrange them based on the orientation, either from top to bottom or from left to right. Another really simple yet very powerful layout that I use a lot in my own Xamarin.Forms apps is absolute layout. It allows us to position our elements pixel perfectly. And you might say, why is that so powerful? Shouldn't we avoid pixel perfect coordinates? Yeah, you should, but there are situations where you want to say, I want this button to be 100 units wide. That's an absolute value that you pick. So sometimes it makes sense, but the real power of absolute layout is something else. It allows you to use proportional coordinates. And we're going to get back to this later. Essentially, your screen then has coordinates that go from 0 to 1. If you place something at 0, it's going to be all the way to the left, and you place it at 1, it's going to be all the way to the right, independently of the actual resolution. And that's what's making it so powerful. Then we have relative layout. It's a bit more complex. And this container allows us to define the positions of the elements and also the sizes of the child elements by using relationships that are set on the container. So you're going to set up constraints. So you could, for example, position something relative to the left edge, or you could position relative to another control. A constraint can either be a fixed value or it can be something that is dynamically calculated. Next we have the grid. If you, like me, were a web developer in the late 90s or early 2000s, then you probably remember the good old table tag. And you weren't a real HTML hero unless you nested 32 table tags, right? So we abuse table tags for layout purposes. Grid is similar to the HTML table tag. However, grid is really meant for layout. So we encourage you to use that for layout even. Here we're gonna have multiple columns and rows. We're gonna have support for row span, for call span, and we can place our controls in there. And the last one I'd like to bring up here is scroll view. Scroll view is a bit special. Scroll view is a container that is typically wrapped around another container. Or for instance, you wrap a scroll view around a stack layout. Imagine you have this situation where you have a lot of elements that don't fit on one screen. So what do? Well, you want to scroll. So just bring up a new scroll view and set the content of that scroll view to the stack layout that you created, and it will automatically scroll both vertically, horizontally, even in both directions if required. To add or remove views to a layout container or from a container, you insert or remove them from the children collection. And that's a property that is exposed by each layout container. You can add and remove views at runtime dynamically. It's going to update your UI. And the order the views appear in the collection determines the order they are drawn and appear on the screen. And that's particularly important with containers that allow for overlapping views, such as the grid or the relative layout. Also, absolute layout falls into that category, because that's going to determine which view is going to be on top. Let's quickly look at how to use some of these containers. The first one we want to inspect is stack layout. It's the most common one. I said that before, so let's focus a bit on that. It organizes content in one of two ways that is based on the value of the orientation property. It's either top to bottom, also vertically, which is the default, or left to right, which is horizontally. Here's an example. We create a stack layout. We set the orientation to vertical, even though we wouldn't have to do that. Remember, that's the default value. And then we add 3 child elements. Here we add a new label, a text input field, and a button. So that's going to mean the label is going to be at the very top. Then it's going to show the entry in the mitten and the button at the bottom. Here's another one. Grid is also very popular. It has a lot common with the grid that you find in WPF or also in Silverlight. It supports stacking things in both directions, kind of a table format, rows and columns. Like I said, pretty similar to the HTML table tag. Columns and rows, they're all 0 based. 0 is the first column, it's also the first row. And each child element has values associated with it to determine which column and row it should be in. If you don't set the row or column, then the child is going to assume column-row combination of 0. It also supports spanning columns and rows, which you can see here for our blue field, which has a row span of 2. And it also allows for overlapping children. So this is useful to add background colors or images into your design. Again, we want to have a look at an example, of course. This is what it would look like in code. We first create our elements, our child elements. Here we have a label. Then we create our grid. And we add the label into the grid's children collection. And what is interesting, by default, our label would now show up at column 0, row 0, because that's the default value for row and column. And if we look at our label, we will not find a method or a property that would allow us to change that. So there is no grid column property and no grid row property. Instead, we find these methods as static methods on the grid itself. So here's a set column and a set row, a set col span and a set row span. And we tell the grid here for that label, make it appear in column 1 in our case and in row 1. There's also a shorthand syntax for that you can use. It allows you to specify row, column, and the spans directly on the add method. So I guess that's the preferred way of writing it. So here we again have our grid, and we add the label, and we directly specify we want to place it to column 0 and row 1, or here for the button, which is the second child element, we also specify the spannings. By default, our grid is going to create a uniform shape based on the largest column and also the largest row that is defined by the child elements. However, you can also take full control of the shape, and you can even introduce empty columns. Sometimes that's nice for layout purposes, so you get extra spacing. And this is done by creating column definitions and row definition objects. Now let's have a look at that. First, let's add a row into the grid. Notice that we create a row definition object, and we set its height property to a grid length object. Grid length, that allows us to specify a numeric value and a unit type. And these two in combination are really important. I'm going to see that here. We say we want that to be 100 units absolute. Absolute means that's going to be points on iOS, it's going to be density independent pixels on Android, etc. That's the height that we specify here. Let's have a look at another example. Here we are creating another row, and we have a value of 1, and the grid unit type is now set to auto. Setting auto means that the grid is going to scan all the child elements in that row, and it's going to select the largest one, and then it will make the row exactly the correct size, so that it's going to fit all of the views. And what about the numeric value here? Well, in this case, when you use grid unit type.auto, the numeric value will simply be ignored, and we should set it to 1. Now the last example, is creating a single column that is star-sized. And this means that the column size will be determined by the available space. So not by the content, but by the space around it. And here the number that is passed in, the one that we have here, this now really has a meaning because it is a multiplier. It determines the ratio between other columns that are also star-sized. So to give you an example, if we had two star-sized columns, both with a 1 as the multiplier, then the available space for the grid, that would be divided equally between them. 50% for the first column or row and 50% for the other. Now, if one of those star-sized columns or rows had 2 as the multiplier, then that row or column would get twice the space as the other column. And since this is a double value that you can specify here, you can also pass in things like 0.5, or you can say this column gets 1 times 3 the space compared to the other. And this allows for very, very powerful layouts. Since grid is such an interesting layout type, I thought let's have a closer look at it, and I want to run a short demo on it. Here I'm again in Visual Studio, and I created this, now at the moment, basic Xamarin.Forms solution. You see it still contains only what is provided by the template. And what I would like to show you is how we can use grid to generate something like a phone dial pad. Now let's go ahead and first clean up a bit in here. Remember in our other demos we created a home page. I'm gonna use the same approach here. I'm gonna create a new dial page in here. And I want to add that. That's going to be a new Xamarin.Forms page. Add a new item, forms page, and we call it dial page. And we see how easy it is to use grid here. So let's quickly think about what this phone pad should look like. What I want to create is something where I have the numbers, like I'm gonna have 1, 2, 3 here, then I want to have 4, 5, 6 there, I want to have 7, 8, 9 there, and at the top I would like to show, spanning all of the columns, I would like to show all of the dialed digits so far, and at the bottom, of course, centered, I would like to have a 0, also spanning here all the way from the left to the right. A great ASCII art here. Now let's see what this is going to look like when using a Xamarin.Forms grid. And we start by first creating our grid. So that's going to be a new grid. And our grid is then going to be assigned to the content node of this page. I'll do this right now. And step 1 in the grid is to set up the row and column definitions. So if we look at our design here, we have 1, 2, 3, 4, we have 5 rows. So let's set that up. We set our row definitions. We're simply going to add them in here. Add a row definition object. And now we have to think, what height should our rows have? I could use a fixed height, or I could say, well, I know I'm going to run this on phone-like devices. I want to use it whatever screen space we have available. So I'm going to use star-based sizing. So we say our height equals to a new grid length. And the no curly braces, of course, just regular braces. The first one is the actual value, and then we have the grid unit type here, and we say our row is going to be star. I'm going to repeat this, and the 4 rows that I create here now, those will be the ones for the 0, for the 1, 2, 3, 4, 5, 6, and 7, 8, 9. So all of these rows should have the same height. However, I don't want to specify the actual height. I'm just saying all of them should use the same height. And then my 5th row, the one that's going to be used for the label that will display the dialed number, that one should use more than the row height. And I'm just going to add another definition here. And maybe we say this row should maybe have 1.4 times whatever the others have. So now Forms is taking care of sharing the available space, making those four all the same size and this one slightly larger. Next thing I need are my columns. It's going to look similarly. I'm going to have column definitions. Let me add the first one, new column definition. Column definition does not have a height, but instead it's got a width, but it's exactly the same grid length object. New grid length here. And again, looking at my layout here, I probably make this star size 2, but here all 3 of my columns in this case will have the same size. So let's just use a grid unit type of star here. And I want to repeat this 2 more times here. So that's my grid. And now I'm going to add my controls in there. So this one here that says number, that's going to be a static label. I want to add this here. And I'm going to call this number. Make it a new label. I can of course set some properties. I want to set the background color, for instance. Make that maybe black. I'm going to have a white text color. And we're going to use a really large font size, maybe 50 or 60. We'll see. And then add this number label into our grid. I'm going to use the grid's children collection. And we find specialized add methods in here. Here's the one that only takes the item, which means it's going to end up at column 0, row 0. And we have another override where we specify the view and the column and the row, 0 based. And we have this one here where we specify left, right, top, and bottom. And top and bottom, they really help me to define the row span or the call span and the row span. It's a bit tricky to use those. So let me see. We're going to add the number. And we use this override. So the number, maybe I can scroll this in view again. Yeah, I can. The number is going to start at row 0, column 0. So both top and left will be 0, 0, 0. Actually, you see that's left, right, top, bottom. So left will be 0. Now the question is, what is right? And right is not the number of columns that are spanned. Right is the column that is not included. So how many columns do we have here? We have 3 columns. That means the index goes from 0 all the way up to 2. And then our right column that is no longer included, that will be 3. And maybe I should use this here to make it clearer what the values are. So we have left, right. Our top is going to be 0, the first row. And the bottom row will be 1. So 1 is not included. That's our number that got added here. And the remaining controls that we have, 0 to 9, those will all be buttons. Now I don't want to repeat myself here over and over again, so we'll add a little helper method in here, which returns me a view, or could also return a button. I'm going to name it create button, and my button can have a text. We create an instance of a button in here and return it. The text of my button, that will be the text I pass to the method. And again, some color here. Let's make the background dark blue. And we have a text color yellow. Reminds me of the good old days, yellow font on blue background. Turbo Pascal that was using these color combinations. So what else do we need? Yeah, maybe we want to specify a font. Of course, we could do that. And we're going to use a bold system font. So it's font dot system font of size. Well, I gotta guess the size, maybe 30. And the font attributes, they're gonna be bold. And all of our buttons, if they are tapped, they should update our number, our label there. So we're gonna assign a click handler here, button.clicked plus equals. I'm gonna use a lambda, I'm gonna have sender and arguments. And now I need to make my number here a field. So I'm gonna rename it. Let's just call it underscore number, and we will set its text and just append whatever the current button has as a text value. So I'm gonna cast my sender back to a button and access its text value. Then I gotta change this one here. Let's remove that, and I will add a field in here, label number, and use the IDE to rename that like that. That looks better. We already added our number label. Now let's create and add those buttons. It's going to be 3 times 3 buttons plus the 0, and we will start with this row here with the 7, 8, 9. Again, I'm going to use grid.children.add, and we add a new button. So create a button. The first one we add, that will be 7. And here we don't have to specify any call spans or row spans, so we simply set left and right, and the 7 that will go in column 0. So you're going to make a left 0. And our top, that will be row 1. Row 0 is what the number label already occupies, so this is what we need here. And I'm going to repeat this 3 times, so we have 7, 8, and 9 here. The row always stays the same, and we go into column 1 and 2. Now let's repeat this. The next one that we have here is 4, 5, 6. Again, column stays the same, 0, 1, 2, but now our row increases. We always have row 2. Now we're gonna do this once more. Scroll that a bit up so you can see it better. We have 1, 2, 3, which goes into row 3. And the last one, that will be our 0. Grid.children.add. We can create another button here. We can also use another approach here. We saw that before, so maybe let's try that just to see that there are alternative versions. So we have our button 0 here. We create a button, and that's going to be the 0. And now we can use the grid to set the column, the row spans, the call spans explicitly on that button. So here we can say set column for a specific object. Here's the button 0. And our column, well, that will be 0, doesn't change. We could also omit that call. 0 is the default value. I want to set the row, so it's going to be 0. And now we can also set the call span and the row span. So in our case here, we don't have a specific row span, but we want to have a column span. So again, my button here. And now I just set the column span to the actual value, and we have 3 columns. The 0 is supposed to span all of them. So here I simply use the 3. I don't have to do any math, exclude the last column or exclude the last row. So this is really a span, where here it's top and bottom excluded. So these are alternative versions. And of course, yeah, I would have to add my button to the grid. I forgot that. Grid.children.add button 0, like this. And this should do the trick. Let's see if it works. It's a lot of UI code now. I said that before. Later we will have a session about how to use XAML with Xamarin.Forms. If you create the same UI using XAML, it's so much easier to read. But again, here we just focus on the code-only approach, and then later talk about the more advanced approach with XAML and bindings. So let me run this here. Let's try Android. I'm curious what the color combination is going to look like. And white screen. And we have the 0 is missing. Oh, we have the 0 up there. Look what I did. The topmost row is of course 0. We wanted to add our button here to the last row. Let me fix that. Here we go. So that's of course not row 0, but that's row number 4. Let's run this again. Yeah, that happens. But now it should all be good. But I can tell already now I like the color scheme. Here it is. You see, I can type here and everything appears up here. And of course I can rotate the device. Wonder what that's gonna look like. I see it's gonna squeeze the buttons a bit vertically, but this still works as expected. All good. Let's try another platform. Want to have a look at iOS. Set as a startup project. Run it on iPhone 5S. And here we go. There's the simulator. App is starting. You see we have our UI here on iOS. Working exactly the same. Again, rotation is supported. Now if you think about it, if you had to create that for both of these platforms, make it dynamically adjust, the auto layout system alone on iOS can be very, very hard to learn, a very steep learning curve. So even though it's all in code here, it's still a lot easier to use forms here. So let's try UWP. UWP is always nice because we can resize the window. So this will show us how the grid, how the layout dynamically adjusts. I'm ready to resize. So there it is. Type something, and of course I can just take the corner of the window here if I get it. Come on. And it resizes. I wonder if I can take it here. I see it nicely adjusts, working as expected. So that's grid. And that brings us back to the slides. Next one we look at is relative layout. That's the one with the constraints. There are similar variations on Android, and the idea is here that we specify expressions that are evaluated at runtime, and as a result we get unique positions and sizes for each child view. You can see that the constraint rules, they are added as part of the add method on the children collection, and typically you will need 4 constraints. So you want to make sure that every control has got an X and Y position, a valid width, and a valid height. Now here's absolute layout. That's the final one that we're going to discuss. This allows for 2 approaches. I mentioned that before. First, it supports these absolute positions using units that will be translated into whatever the platform uses. And you can specify it through a point and let the child view decide the size, or you can specify a bounding box that specifies both position and size. So there's an overridden form of the add method, and you see this here as an example. We can either set the position or the entire rectangle. Now what about this proportional positioning? That's where we say the resolution of our screen goes from 0 to 1. And 0, 0, that's top left, and 1, 1, that's bottom right. Now if we want to center something, well, we would position it at 0.5, 0.5. If you want to place something at the top and all the way to the right, that will be 1, 0. Let's have a look at an example. Here's one that is, again, using point or rectangle. Difference this time is the coordinate system. So here all our values, they range from 0 to 1. The rectangle that we're using here is X, Y, width, and height. And all of these can be used proportionally. The last parameter that we pass in here, those are flags, and we can mix and match absolute coordinates and proportional ones. So here we say all of our values should be interpreted as proportional ones. So here we're creating a label that is centered. X is 0.5. It's going to be positioned at the bottom of the container. The Y coordinate is 1. And we want the size to be half the container width and 1/10 of the height. So that's the 0.1 here. Here's another example. Here we take an image. We want the image to fill the entire parent. So again, we just set X and Y to 0. And we set the width and the height both to be 1. That means it's going to consume all of the available space. As you can see, with absolute layout, we can easily specify the width and the height of our controls. But think back to the demo that we saw before. In this UWP project, we had the blue button that stretched the entire width of the screen. The question is, how can we influence the size of a control if it's not embedded into an absolute layout? And the solution is pretty easy. Every control, every view on Xamarin.Forms has got this width request and height request property. So you can see the example here on that slide. We have a button and we request a width of 100 and a height of 75. The layout manager will then try to satisfy this request. However, it doesn't have to. All of our views, they also have a width and height property that will contain the actual calculated width and height. So that's what the layout manager gave to us. The next property that we want to look at is padding. That's available on most containers, also on pages, and it allows us to specify some additional padding around the child elements. So here in this example, we have the stack layout, and at the top, the right, bottom, and the left padding would be applied. We can assign a single numeric value to padding, like 10, which means it's going to be applied at top, bottom, left, right, or padding can be a thickness object. And this means you can specify padding that is going to be used only at the top, or different values for top, bottom, left, right. There's also another constructor, another override that allows you to specify one value for top and bottom and the other one for left and right. And finally, there's the spacing property. Spacing allows you to add space between the child elements in a container. So again, here with our stack layout, between the first and the second, and between the second and the third child element, spacing would be applied. And now I'd say it's time again to see everything in action. I want to switch over to Visual Studio, and we're going to add a layout here. So let's see. Here we have our home page. It has this button in there, which we used as a click counter. And what we're going to do now is, well, we keep the button, but we will add an additional layout. And it's going to be an absolute layout. So I'm going to create that here. It's a new absolute layout. We don't set any parameters, we just stick with the defaults. And we set the layout as the content of our page. And then we can add multiple elements to the layout, and they're going to show up on that page. Let's remove the click counter here. We don't need that. And the page that we build will be the entry page to our exam, to our quiz application here. So that's just going to be a start button. I want to change the text here from click me. So it says start exam. We currently have a dark blue background color. Maybe we want to change that, make it look a bit more friendly. And if we look at our color class here, we see there's a factory method in here. We can also generate colors from RGB, so we're not limited to the pre-created colors. And we have overrides in here for double values and for integer values. And the one that I'm actually looking for is not this one, but is one that allows me to specify a string. So that would be from hex. Here you see you can specify a string value. And then we use the syntax, which is also used in HTML, and the color I'm gonna pick is 0892D0. It's gonna be light blue. We keep the text color white here. And we can also change the font. So let's make that a medium size font here. We set the font. And again, I can use my own font, or I can use a system font. Here I have this system font off size and bold system font off size. I want to use system font off size. Well, now the question is again, what size would be appropriate here? And I said we want to make it medium. And it turns out there are named sizes here. So I have named size.large, medium, micro, small. So let's pick medium here. And using that will allow Xamarin.Forms to adjust the size of that font. So maybe you inspected the accessibility settings that are available on all platforms. There you can adjust the global font size that is used. And good apps, they make use of this feature. So here, by setting a size of medium, it's automatically going to adjust to that. So that's our button. And our button has currently no handler, so we want to get rid of this. Let's just create a placeholder here. I'm going to insert a method in here. And we're going to call that, I'm going to rename it here, say on start clicked. Remove this here. Let's not throw it a not implemented exception, just not going to do anything. We're going to fix that later. So here we go, we have the clicked event. We don't need this here anymore. We get rid of our stack layout in here. We are already assigning the absolute layout. And well, let's see what this looks like here. Oh, actually, we're not adding the button yet, so we are missing out on that part. So let's fix that. We're gonna add our button, of course. Here we have the layout, and we use the children collection. And we want to add something. You see here we have these various overrides. We have one where we just add the item, one where we can specify the position, another one where we can specify the rectangles, and also the layout flags, whether it's proportional or absolute coordinates. So here I'm going to add my button. And I'm going to use a mixture of proportional and absolute absolute coordinates. So let's define the entire bounding box. We specify a rectangle here, and we say we want to center it, so that we 0.5, both center horizontally and vertically. But we want to use a specific width and height. So here I say my width is going to be 200 units, and the height is going to be 60. And now I have to tell the absolute layout which of my coordinates are actually proportional and which are absolute. So we use absolute layout flags. And we can see there are predefined settings here. So here we have position proportional, which means X and Y are proportional. width and height are absolute. That's exactly what we need. There's also size proportional, width proportional, X and Y, and you can combine them. So for instance, you would say my X coordinate is proportional, you would use that, and then you would create an OR combination of maybe height proportional. So then you would have proportional X coordinate, proportional height coordinate, and the other two would be absolute. So here we are happy with the position proportional. And missing a semicolon here. And then let's run this. I'm going to try it here on Android. We should see it. Emulator is starting, or the app is starting. And here it is, start exam. And you notice we still have our title bar up here. For the typical start screen, we're later going to add a background here. We probably don't want that title bar up here. And to fix this, we can go back here into our home page and add a call to a little method here, which is the navigation page actually, and it's set has navigation bar. And here we want to set this for a specific page. Well, the page that we're dealing with is our current page, and the value is false. So this means for this page here, do not show the navigation bar, and we want to try that. Run it again. And come on, there we go. Nice centered button. And of course, I can now go ahead and also run this on other platforms. Let's have a look at iOS. I don't want to run that on the device, but on the simulator. And you see here we have the same application running on iOS. It's a native button, and of course rotation is also supported in here. And no navigation bar anymore. Well, last one, we want to try UWP. Change my config here, x64 is what I want, and run it. And as always, takes a bit to load all the symbols. But then we hopefully get the same nice centered button. Here it is. And if I resize my window here, you see that it remains centered. All of this is working as expected, and we did not assign a handler yet, so clicking the button is not performing any actions. We're going to change that later. So with that, let's go back to the slides. If we look at our UI now, we have a button that's centered, but something is missing. I'm not a designer, but I would say an image would make our UI look so much better. So what a coincidence that we now have a few slides about images. Let's talk about them. The image control, just like the other controls in Xamarin.Forms, has a lot of properties which allow us to influence how the image will be rendered. I can of course specify a width and a height request. I can even set the opacity here. And our image control, our image view, it uses a source to specify where the image should be loaded from. Let's have a closer look at this. All local images are considered resources. And these sorts of resources, they can be included into the application in two ways. First, we can place the resources into each platform-specific project. And this allows us to automatically take advantage of the platform features. So for example, iOS will load resolution-specific images. And on Android, we have these buckets. We have HDPI, XHDPI, and so on as subfolders of the drawable folder. The second approach that we have is we can embed our images directly into a portable class library. So this is of course only available if we create our Forms project based on a PCL, not based on a shared project. And every image that is embedded has to be marked as an embedded resource. Now what sounds great, because it means we will have the images only once and all in a central place. has a downside, that is we lose all the support that the native platforms are giving us. Still, let's have a look at how to use embedded resources. You will typically add a subfolder into your PCL. Here we call it images, and in there we drop our image. Here it's car.jpg. And in the properties, we want to specify that the build action for this image is an embedded resource. In order to load this image then, we have to specify the full resource ID. And the resource ID is generated from the file name, again, case sensitive, that would be car.jpg, and it's going to be prefixed by the full namespace. So here our assembly is exam, the namespace, the full one, means we got to append the folder name, that's exam.images.car.jpg. Let's go ahead and switch over to our app, and we're going to add an image. I'm going to show you both approaches. We're going to start with a platform-specific image and then later move everything into the PCL. So I'm going to take iOS here as my first example. You see we have the resources folder here. If I expand that, we already have a lot of icons in here, and I'm going to add my image in here. So I'm going to right-click here and add an existing item. And this image is already on my desktop. Here's the background.jpg. I'm going to import that. If I look at the properties of this image, bring them up here, you see it's now a bundle resource. Now that's an iOS specific thing, and its name is background.jpg. Next, I'm going to add the image here to Android. Just going to pick these two as my example platforms. We again open resources, and now we have drawable folders. So I could now provide different versions of my background.jpg, but I only have this one, so I'm going to drop it into drawable. Again, we see there's already an icon in there, so we're going to add that, add an existing item, and add exactly the same background.jpg. And if we inspect the properties there, we'll see that it has an Android specific build action over here. Build action is Android resource. That's all I have to do. I can now go ahead and add the image. So let me get rid of the properties here so I have more space. We stay within our home page here, and here's where we add our button. Let's reorganize that a bit. Here we're going to load our image now. So we have our background, which is a new image. Well, we simply set the properties. We have a source, and we use this factory method. We use image source from resource, actually from file. That's what we wanted first. Use the platform specific one, and that's background.jpg. And the other thing that we want to set is the aspect ratio here. And again, there are predefined values that you can use: fill, fit, aspect fill, aspect fit, or just fill. So if we use fill, then the scaling might be distorted. The description says it here. Scaling may not be uniform in X and Y. Aspect fit means it scales the image so it fits the view, and you might end up with black bars left, right, or top, bottom. It's also called letterboxing. And aspect fill means we're always going to use all the space that is available. Even that means we got to clip some of our some parts of our image. That's what I want to use here. So let's do this here, aspect fill. Well, and then we're going to add this here to our layout. And I want to make sure that my button that I have here is on top of the image. So I'm going to cut the button here and move it down here. And before we add the button, I'm going to add the image. So layout.children.add, and we add the background. And again, we specify a rectangle just like before. However, this time everything is going to be proportional, because we want the image to use the entire screen space. So that would be 0, 0, 1, 1, and we say everything we have here is proportional. There we go. Now let's try this. I'm going to start with iOS, iPhone simulator, and we run the iOS project. Well, let's try this out. And let's see, launch screen, and we have this nice chalkboard as the background now. Looking great, huh? So let's try Android. Go back here, run the any CPU configuration, select Android, and put it up here. Shouldn't take too long since the emulator is already started. And here we go. And as you can see, we also have our background image here, again loaded from the platform specific resources, this time from the resources/drawable folder. And of course, the alternative approach, that's what we finally going to use here, where we load the image from the embedded resources. Let's change that. Stop debugging here. Our Forms project is based on a portable class library. Here we have it. So let's move the image in there. Well, first of all, we remove it here from the platform specific projects, delete it from Android. Yep, we're going to remove this here, and we also remove it from iOS. Background.jpg, delete that. Well, let me collapse those. And instead, we're going to add it in here. And I'm going to create a new folder here, add new folder, which I call images. And in there, I will add now the background JPEG, add an existing item just like before, same JPEG. And we select it and inspect the properties. The default build action is set to content. We want to change this so it is a embedded resource. Here we go. Leave the properties again, and we have to adjust our code a bit. Currently we are using the from file method. I'm going to change this to a from resource, and if we use from resource, we have to specify the complete namespace. This will not work here, so our namespace, that's exam, the folder name plus the file name, like this. And again, I will run it on various platforms. Let's start with Android as it's currently selected. No surprises here, just like before, we see the background image. However, this time it's loaded from an embedded resource and no longer from the platform directly. And we're back to PowerPoint. And what do you think? My opinion is we created a real nice polished starter solution, and we can certainly add additional features, so stay tuned while my colleagues tell you more about Xamarin.Forms. I would like to take the time to recap what we have learned today. We saw that Xamarin.Forms is a cross-platform UI framework. We support iOS, Android, and the Windows platforms. We create our UI and also the business logic all in one single project. That project is either a shared project or it is a PCL. We also talked about the differences between shared projects and PCLs. Both have their advantages but also disadvantages. With shared projects, we share code at a source level and we have access to all the native features. With a PCL, we share at a binary level. We do not have access to the platform features directly. We have to work with abstractions, but we can share the resulting DLL, we can build it separately, and we don't have to give away our source code. The UI that Xamarin.Forms is using is really just a model. And at runtime, this model will be turned into platform-specific controls. We talked about the example of a button. When we create a Xamarin.Forms button, it will turn into a button widget on Android, it will turn into a UI button on iOS, and so on. The controls themselves, that's not where Xamarin.Forms stops. We also saw that we have access to a very powerful layout engine. With that layout engine, we are able to just throw some controls at forms and say, place them on the screen for me and align them nicely, make sure that all of this works on different form factors, We saw how I resized the UWP window. My button stayed exactly in the center, so I don't have to worry about adjusting my controls, moving them around. If you would like to learn more, we have free self-guided courses over at Xamarin University. You find that at university.xamarin.com/self-guided. And I would like to point out again, these are free self-guided courses. You can attend all of the intro classes there. And if you think, yeah, that's certainly something that I would like to get more involved in, feel free to upgrade to a full subscription, which gives you access to a lot of live classes, advanced content, not only about Xamarin Forms. We also cover iOS development with Xamarin, Android development, and we cover, of course, Azure there, how to test our app, how to write UI tests, etc. All of this over at university.xamarin.com. And now I'd like to hand it over to my dear colleague Jesse, who will show you how to use XAML in Xamarin Forms and use a declarative way of creating pages. He'll also give you an introduction to data binding. Data binding greatly simplifies how our data moves from the model into the UI and also back again. So stay tuned, that would be really cool. Later, Jason is going to show you how to connect our app here to Azure. So our app is going to show different questions, and we want to pull those from the Azure cloud. And finally, every app should be thoroughly tested. That's when Glenn is going to take over, and he will show you how to use Xamarin Test Recorder to record UI tests and then deploy those tests to Xamarin Test Cloud, run our app on hundreds of devices, run automated UI tests, and get error reporting. Thanks for watching, and hoping to see you soon at Xamarin University.